people who are watching this show that you truly like what we're doing, because we're the only thing between you and a long weekend. And so I just want to say thank you for attending. I think we're going to have a really good experience. We've got some really wonderful guests with us here today. My name is Phaedra Corso, and I'm the Vice President for Research here at Kennesaw State University. And we started this show last spring, and it's been very successful. Our point for doing this is to stay connected as collaborators during this somewhat strange time, and also to highlight some of our amazing faculty who are doing research with relevance and who are doing interdisciplinary research. We had a great show 2 weeks ago where we featured Linda Schreiber and Jackie Jones, and I think I see Linda, so welcome back as not as a participant, but as an observer this time. And they did a great show on nurses' experience with medication errors, and I think we all learned a lot from them, and so that was wonderful. Before we get started, I do want to share with you some pretty exciting news coming out of the Office of Research. Out of the Office of Undergraduate Research in particular. So many of you will remember that last year we launched our first year scholars program, and we were pretty excited about it. We had 10 pairs of freshmen paired with outstanding research faculty, and we gave them a little bit of money to see what they could do and to get those freshmen excited about being here at KSU and excited about research. And that program was so successful last year that we decided to go all out. And we did some pretty significant recruiting of faculty to participate this year. And we're proud to say that we have 70 plus faculty who have submitted projects for freshmen to compete for to be on their teams. 70. We went from 10 to 70 in 1 year, and we are just absolutely thrilled. Joelle, if you could put that slide up to show what is our next step in this process. So we have the projects, and now we need to get students excited. And if I don't see the slide, I don't know if anybody else does. I still
it's in the chat.
Could we see it?
Yes, give me 1 second.
Sure. So the next thing we need to do is find the students to participate. And so what I'm asking all of you to do is to find your favorite freshman in your class and say, please go to this website that we're going to show you in just 1 second and apply for the program. So this is the website right here.
This is the graphic, but I can show you the website. Do you want the website instead?
So I want to show the website only because I think you did a great job on it, and I want to show how easy it's going to be for students to apply.
Okay, I'll get that up. Sorry.
Yep, thank you. So we're going to be marketing in every way that we know how. So we'll be using all of our social media. I'll be reaching out to the Research Advisory Committee to distribute to faculty, but we're really looking for you all to find students for us to apply for the program. We're very excited about that. So we'll see that graphic in a second for you to see how the projects are laid out. Here we go. That's Joelle. So here's the website. So we've got it, I think, managed very well in that a student can look at all the projects within a particular college. We want to be really clear that students don't have to stay within their own college. And in fact, we should be promoting interdisciplinary research. So students applying for projects outside of their discipline is perfectly acceptable. So at each one of those cubes, if you open it up, it will tell you the list of all the projects that are available. Some of the projects have a video that the faculty have made that describe the project, or otherwise it just has a short description. So anyway, please know that we'll be looking for those students. The deadline is September 18th. Our goal is to have 70 projects with pairs. All right, so let's go with the show. So let me just remind you of a few housekeeping tips. Please make sure your mic is muted. I see that everybody has done that already, so that's wonderful. If you want to see the speakers in larger view, then there's the ability to pin them, which is the 3 dots next to their name. And then we also wanted to remind you that today's show is recorded, as we always do, and it will be available on YouTube later tonight to share with your friends and family. That's always fun. So our schedule for this next hour is that we will be watching a video, which is an overview of our featured researchers today. And the featured researchers today are Ayse Tekes and Tris Utschig. We are very excited to welcome Ayse and Tris to the show. They are both from the Southern Polytechnic College of Engineering and Engineering Technology, and they will be sharing with us today their mutual interests in involving students, and that is the key, involving students in research and hands-on learning that brought them together for this current project. And, you know, I meet faculty every day, all the time, as we all do. And I will tell you that when I first met Ayse, I wanted to be her. She has a passion for students like I have never seen before, and it is infectious. I hate to use that word right now, but it's an infectious passion, and we are just so excited to have you here at KSU. I just met Tris this week, but I've heard so many wonderful things about him, and he also has the same passion for learning and improving the learning processes of our students. And so this is, I think the two of you are really a phenomenal pair. Ayse is an assistant professor in mechanical engineering in the Department of Mechanical Engineering. And your dean's face just popped up on my cube, so I imagine he'll have some questions for you. Ayse has been at Kennesaw State University for the last 4 years, and her research interests focus primarily on the design, analysis, and control of compliant mechanisms, as well as small-scale lab equipment design for dynamics, vibrations, and control labs. And you can see she is sitting there in her lab and will be showing us some of these beautiful things that she and her students have created. Tris is the director for scholarly teaching in KSU's Center for Excellence in Teaching and Learning, or CETL as we know it. And in his full-time role in CETL, his work involves supporting faculty to incorporate research on teaching and learning within their classrooms, especially in the STEM disciplines. And this is an area that many of us have an interest in, and we hope to work with Tris and expanding our capabilities over these next couple of years. Tris joined the KSU faculty in 2016, and he's also an associate professor of nuclear engineering in the same department as Ayse. And he earned his PhD in engineering physics, fusion technology from the University of Wisconsin-Madison. So I'm going to be quiet and mute my mic, and we're going to let Heather play the video.
My name is Ayse Tekes, and I'm an assistant professor of mechanical engineering in the Southern Polytechnic College of Engineering and Engineering Technology. I have always been interested in the design, modeling, and control of compliance, in other words, flexible mechanisms, within the focus of my PhD program. And during my time as a postdoctoral researcher at the Georgia Institute of Technology, I developed mathematical models of capacitive micromachined ultrasonic transducers, considered the breakthrough ultrasound technology. My current research interest in small-scale lab equipment design for dynamics, vibrations, and control labs stemmed from a 2017 IEEE American Control Conference, a highly prestigious international conference in the area of controls. During an invited session, there was a discussion about the need to develop low-cost laboratory equipment for control theory courses. This was also an issue for vibrations courses and the associated labs, since students usually struggle with complex equations and connecting the theories to the real-world applications. I recognize that portable lab kits for these hands-on experiences could greatly improve learning if the students were able to take the lab equipment home to complete experiments on their own time. In dynamics, vibrations, and introductory control theory courses, undergraduate engineering students to develop and use mathematical models of mechanical, electrical, and electromechanical systems. To better understand the fundamentals of vibrations and control theory, students need to establish a solid foundation in dynamics, which studies the motion of these systems and mechanisms as they respond to various conditions. In engineering, these three courses are taught along with the associated labs. However, currently available standard educational systems used to demonstrate vibrations and control concepts are often limited. They are costly, few in number, and require substantial physical space. For these reasons, most students do not get a chance to spend enough time on the hands-on part of a lab. Although an increase in lab time could be a solution, Common obstacles may arise, such as the lack of extra time due to the students' other time commitments, the lack of equipment access during nights and weekends, or the lack of class offerings that would include enrolling in theory lecture courses and applied lab courses during the same semester. We want to change that.
My name is Dr. Tris Utschig, and I am an Associate Professor of Nuclear Engineering in the Southern Polytechnic College of Engineering and Engineering Technology. In graduate school, I was a nuclear engineer expecting to apply my research at a national lab designing fusion reactors. However, after earning my master's degree, my plans changed dramatically. I joined the Peace Corps, in which I was assigned as a high school math and science teacher in Ghana. From that unique experience, I found that I also loved teaching. The more I learned about educational research and best teaching practices, the more motivated I became to advance and apply that research to the engineering curriculum. While I still teach nuclear and mechanical engineering courses, most of my work now involves supporting faculty to incorporate research on teaching and learning within their engineering classrooms. I do that through my full-time role as Director for Scholarly Teaching in the Center for Excellence in Teaching and Learning. I conduct engineering education research, exploring the frontiers of student learning. I seek new ways to help students not only to learn the content, but to connect it to the real world and develop the same learning and professional practices used by engineers out in the workforce.
I established my own research team, the Dynamics and Control Research Group, in spring 2017, with an aim to design compliant mechanisms and portable lab equipment. When Tris joined the Mechanical Engineering department, I was happy to learn that his work fits well with the goals I had for the student-designed 3D-printed portable lab equipment for dynamics, vibrations, and control theory courses and their associated laboratories. So I asked him for a meeting, and at first, we started talking about how to turn the student-designed research projects I was supervising into an educational journal publication.
Yes, so as it turned out, our interests aligned perfectly. The research that Ayse was doing had amazing potential for use in the lab, in the classroom, and even for individual students working at home. The research I am interested in connects that hands-on work in building up students' engineering professional skills while also fostering deep learning. Together, Ayse and I bring expertise forming a complete set of research knowledge for use of these devices in support of undergraduate learning. It starts with students designing and building 3D printed devices in Ayse's design group. Next, we translate the physical behavior of those devices into carefully designed learning activities connecting to the theory in class or lab. And then, when students complete the learning activities connected to each device, they build real-world engineering skills based on some of the most complex, conceptual, and highly mathematical content in the mechanical engineering curriculum.
Teaching abstract mechanical engineering theories using student-designed 3D-printed lab equipment encompasses a technical research approach embedded within an educational research environment. While the overarching goal involves educational research to improve undergraduate education in STEM, science, technology, engineering, and mathematics, our educational innovation utilizes engineering hands-on equipment that students will design through a technical engineering research process. We have a 5-pronged approach to this process. First, the developed mechanisms are low-cost, light-weighted, and compact, since they are 3D printed using thermoplastic polyurethane, polylactic acid, polyethylene terephthalate glycol filaments. Since the model is created using CAD software and posted online, anyone can download the CAD model to 3D print the specific device using a low-cost home-based 3D printer. Second, the idea of using compliant or flexible mechanisms is catching on. Traditionally, when engineers design a mechanism, they prefer rigid parts connected with hinges or sliding joints. But when we look at nature, we see an entirely different idea. Moving things in nature are very flexible instead of stiff, and the motion or displacement comes from bending. We see in nature the possibility of making devices or machines that are very compact, even with their own control and energy harvesting systems. And third, the mechanisms can be used in several courses.
Fourth, students teaching students is part of what makes this research so relevant. In 2018, the students in Ayse's design group produced several devices for demonstration in class. I worked with Ayse to design the learning activities, and in class, the design group students were there to assist students in operating the devices, manipulating them to change their vibratory behavior, and interpreting the data produced by the sensors. We then collected data showing the impact these activities had on student learning, and saw encouraging results. As students working in the design lab bring their work directly into the classroom, they make the content come alive in the courses we are trying to impact. No longer are students simply doing the math to analyze a theoretical system. The activities students lead and participate in are designed to be active, hands-on, and process-oriented, which research demonstrates can increase student learning, increase student innovation, and increase self-efficacy and identity as engineers. In short, what we are trying to do is to prepare students to graduate from KSU with all the skills needed for their professional jobs. We are studying the impact of how strongly students develop certain characteristics expected of working engineers from utilizing our 3D printed lab equipment. And lastly, low-cost data acquisition is readily available through the use of our 3D printed lab equipment. The turnkey systems that are usually installed in lab spaces are purchased with integrated software and instrumentation ready to collect data, making it easy for the students. However, the students do not have the opportunity to develop a deep understanding of connecting sensors to the power source and data acquisition system. And, since these turnkey systems are not designed for use in classroom demonstrations or for short hands-on activities, opportunities for student learning through concrete hands-on experience with the equipment is restricted to very basic manipulation or even to pure observation.
With the coronavirus pandemic, the spring 2020 semester moved to online instruction, leaving professors to quickly prepare for a virtual environment they were not anticipating. Whatever the circumstance, engineering labs still require plenty of hands-on learning. The usage of our 3D printed lab equipment is the ideal solution since it can be used in various environments. Students can perform lab work at home and get hands-on experience through the lab kits that can be mailed to their homes or picked from campus for usage at home. Through it all, my number one priority remains the same. My students, having engaged in research, will be better prepared for future careers both in industry and academia.
Students are attracted to the project not only because of Ayse's boundless enthusiasm, but also because they love working on these projects, as they see their skills in critical thinking, problem solving, and engineering design are all elevated far beyond what one normally can achieve with traditional classroom learning. We hope to transform how faculty facilitate student learning of vibrations and controls content throughout the mechanical engineering curriculum, from well-designed learning activities in the classroom to hands-on experimentation in the lab, and even to studying at home.
Great. Thank you. That was a great video. And thank you again, to my team who, and to our presenters today, but also to my team who spent some time preparing that video, to Tom and Joelle and Heather. So thank you for that. So obviously we're going to talk about your students in great detail because that's where your passion lies. But let's look at all these fun things in front of you to start off with, Ayse. So this is a world outside of mine. So if I'm a new student coming into your lab, what is your first way that you get me excited about the research that you're doing?
Hi, Phaedra. So I will just say that we start with free vibrations first, like no actuation needed. And in the courses that I teach, the very first thing I do in the classroom is I spend almost 30 minutes explaining about my research. I have two main research going on right now. One of them is, as you mentioned, design, control, and development of compliant mechanisms. Compliant means anything has the tendency to bend. And we replace all these traditional rigid links with their compliant counterparts. And they love these kind of projects. And I know that my students, their strength, so far I have observed, my students have their strength in the hands-on applications. And actually their strength is designing really complex systems. And I showed their pictures of all my students, which created those mechanisms before. I share them with my new students. And it usually takes my 30 minutes in my first class period. And I also mentioned about this 3D printed portable lab equipment. They just fell in love with that project too, because this is something they want to have while learning the topic. Because, engineering courses, they're highly mathematical, and vast majority of our students struggle in the math, which is completely fine. The topic itself is also really concrete and also not easy to understand, comprehend at first. But giving them ability to actually work on the mechanisms or the 3D portable lab equipment while I teach the topic. They just like it because they learn way better if you provide them some kind of hands-on experience while they can collect data also and actually implement the theory into an applied research. And this is probably one reason they want to be part of our team. And I'm very happy with that. My students are actually the drivers of this research.
So at what point in their engineering career at KSU do you get them into your lab? Do they come in as freshmen? Do they come through a course and you select the best? I mean, how does it work for a student to be working with you in your lab, your research lab, as opposed to just in the classroom?
I teach dynamics, vibrations, control theory, and their associated laboratories. Unfortunately, I do not see freshman students. Last year with the hours, like first year scholars, I had one student as a freshman. But other than that, most of my students are juniors and seniors. And once juniors become seniors, they train my new students. This is how the team works. Like I have a team of students, but the seniors, they train the junior students how to use the 3D printer, how to design compliant systems in SolidWorks, and how to do FA analysis in ANSYS or COMSOL. We have all these software in our computers in the lab. So they really help the new students, but they're mostly juniors and seniors because of the courses I teach. So once I just demonstrate what I'm doing in the first period of my classroom in the semester, in the beginning of the semester, students usually start emailing me. And this is, I don't have a selection. Whoever wants to be in, I just have a first meeting with them. I tell them that, okay, guys, once you're in, you're in. You should never disappear. Don't ever be scared of failing, because failing is a way of learning. And please do not get upset if you fail on the first project. We always fail, and we learn from our failures. Just be patient in the research, but do never disappear. If you want to stick to that rule, part of it. This is only my rule. Like my only expectation from my students is not just to disappear. We stick to it.
Got it. And I'm going to switch over to you, Tris, for a second. So part of the research is that I heard you say on the video is looking at the impact on the students. And I guess I would like to learn how you assess impact. What are the practical ways one assesses impact?
Sure, yeah, that's a great question. So you might think that what we're really just looking at is, do students score better on tests by using this equipment in the classroom as opposed to not using it? And we do look at that. But really, my research and my work in the Center for Excellence in Teaching and Learning is trying to support our faculty to develop the whole professional that the students are trying to become. So we're looking at impacts that are well beyond just scores on the test, and that includes, for example, their identity as an engineer. So does the fact that they can physically connect the sensors on this equipment and see how the data is collected in a raw form and then manipulate it to produce data that they can analyze, help them become, have more of a sense of an engineer? Or how does it affect their motivation? So sometimes students will lose perseverance when they're doing all this math, and they don't actually see how something really works. So this is a chance for them to really work with the material, and we're studying whether it's impacting their motivation. And then beyond that, there are a couple of instruments we're looking at in this work that involve the student's sense of their engineering skills, and we're basing this off of the profile of a quality engineer that was developed out in Washington State by Denny Davis, to see how closely they can align with that and what their changes are in their view of themselves as engineers, and also as quality learners. So there's a variety of ways we're looking that are well beyond just how they're doing in the course in terms of their assignment or test scores.
Great, thank you. So tell me, what are some of the things that your students have accomplished while being on your team, Ayse?
Yeah, from day one, I'm impressed from day one. And when I first started in 2016, I remember my first meeting with my department chair. At the moment, it was Dr. Lori Lauder. And she asked me the same question: what's your goal? A typical question that you ask your new faculty. And I said, I want to build my own team. So this was always a dream to me. But then starting with zero initial funding and no facilities around, and I was kind of stuck. And one day I remember myself, after teaching a 6:30 p.m. control theory class, I was still in the classroom looking at some papers to actually initiate my own research here at KSU. One of my students approached me. I didn't realize he was next to me. I was looking at a paper, and he was with me for 5-10 minutes watching me. And I just, lifted my head and I said, okay, do you have a question? He said, how can I help you? That was his question. He said that, what are you doing? I said, I'm just trying to read this paper and initiate something here at KSU. And he was like, can I be part of it? Or how can I be part of it? I want to help you. And I just looked at him and I smiled at him. And I was like, okay, let's do this then. Let's build something together. And since then, I'm working with them. Their passion motivates me. I don't motivate them. Their passion motivates me. And they have accomplished many because students are publishing crazily. They're publishing their conference papers at ASME Dynamic Systems and Control conferences, ASME IMECI conferences. They're publishing journals. They're attending all these local conferences, and their ambition, their willingness to complete the project is significant. And you just look at them, and you cannot stop after you see their passion.
You are it. You're the passion. I would work with you if you would take me. I'm going to brag on Ayse and Tris just a little bit more. And for those of you who are listening who don't know, they just received an NSF grant to support the work that they're talking about here today. And not only did they get an NSF grant, but they got it first time out of the chute, which is, I think, just so wonderful. And I guess I wanted to hear from you, from the two of you, on how did you get to that point? Because lots of us want to be successful in getting NSF and NIH grants, but how did you do it?
So, Tris, I'll start and pass it to you if it's okay.
Sure, sounds great.
Okay. So what happened is I was twice the panelist at NSF CMMI panel, and during that panel conversation, seeing the proposals and the complexity, I was like, okay, I want to bring in NSF funding, but probably it's not going to be from CMMI. Not now, not today. So I was looking at other ways to bring in NSF proposal with some research, because I had my research on modeling, dynamics, and control area. I've never done a research with developing portable lab equipments, but I attended a conference in 2017, as in the video just we watched. And here, and in that one, I realized that there is still a demand in developing or lowering the cost of these laboratory equipment. It was in an invited session, and I met with two professors in there from a different institute. And I talked to them, and it was all about control lab equipment, nothing about mechanical engineering. And then I came back and I said, okay, because I teach those courses and I see the struggle in my students. And I always wanted to help them better understand the topic before they graduate. And I was impassioned of designing those portable lab equipment. So the idea started with the aim of developing or lowering the cost of lowering the cost of these educational lab equipment. They're really expensive. You cannot have 5 of them. 5 stations in a lab because they're costly and they require white space, and students who are in the lab, they have to take turns and they have to wait 30 minutes. So it's a loss of time. This is a struggle that I have observed while teaching those courses. That was my idea to actually, I started searching for possible proposals like agencies, and I saw that NSF IUS is a good agent for my proposal. But then next, I met with the program director at NSF. But while I was a panelist second time at NSF CMMI, I asked my program director if there's any way I can see the program director of NSF IUS. And I met with her for 1 hour, and she told me to find a collaborator. So that's how Tris came in. Tris.
Yes, well, I think it was one of the very first department meetings I attended here when I started working at KSU, where after the meeting, Ayse came up to me and said, I have this idea for working on these student research projects to bring into the classroom, and can we meet and talk about that? And I said, well, sure, that sounds great. And I have to be honest, it's one of the projects to me that's been perhaps the most motivating in my career, because not only does it connect to what I'm interested in terms of helping students to become better quality engineers and better learners, but the students are having so much fun, and it's in the classroom and in the design group. So that really helps. I do have to correct you a little bit. It did take us 2 tries to get this IUSE grant. So we submitted a first proposal with just, I think we had 1 device that we had brought into the classroom and used at that time. And then between the first and second time, we had a couple of more devices and several learning activities that we specifically developed for the course. So we had some preliminary data that showed how students were responding. And I think that made a huge difference in revising the proposal for the second time. So when we came with our second version of the proposal, we had already had, I think, 3 papers published and had a significant amount of experience using the devices in the classroom, so that when we were talking about it, we weren't just proposing what we wanted to do, but what we had started to do. So that made a big difference.
Great, thank you. Yeah, sorry about that. I only think about KSU time since I came, not since before I was here. So I apologize about that.
No problem.
I have a billion other questions that I can ask, but I think I'd like to turn it over to those in the audience who might have some questions. And just to remind everybody, you can send in a question through chat if you have that function available to you, or you can just raise your hand or butt in and ask a question.
So this is Ian. So Phaedra, I don't think KSU existed before you arrived here, without doubt. But anyway, my question is quite simple. You know, part of this is really, it's not just about the technology, it's about the learning outcome. It's about how you've equipped the students as they continue their journey through KSU and through our engineering programs. So I don't know, have you been able to do some work and some follow-up to see how, when students have come through their time with you, that they might be better equipped? And do we have a better sense of, you know, if the provost is on the line, DFWs and/or how people's journey has continued, and something that might be measurable? Tris, you can answer this.
I can start with that.
That kind of falls into your bailiwick, right?
Well, it does. And so one thing that we can look at is DFW rates, and that's not data we've explicitly studied at this point, but it is something that we'll be looking at as we move into the program, and we have students with us through multiple semesters, so we can look at, did they just take dynamics with us as a sophomore? Or did they take dynamics and then they took the follow-on course in vibrations? Did they take all 3 possible courses? And we're looking at the impact of that. But what I can say for, and Ayse can talk more about this, but in her design group, that's where we're seeing real impact. So, you know, she can talk more about it, but we have a student who's now graduated and moving on with us. We have students getting job offers based on the experience they're developing in the lab. So there's a real measurable impact already, even before we got the money, that we could see from her design group. And then as we move through the grant, you know, we'll be able to look. We have about 400 students that we'll be able to look at over the course of the grant. So we'll have large enough numbers to see some difference. So
as you know, a lot of ASWE papers end up just saying what we've done. And when you hit the higher end, the FIE papers are that they're really the ones where you've been more purposed at looking what's happening a few years out. And that would certainly be of interest to me.
Maybe Ayse can share the story of at least one student that we know we would want to share in an environment like that.
Yes, I had always like students, especially if I can have a student for more than a year, I'm the luckiest person, because I see the I see the improvement and I see the abilities he's gaining in the lab. Especially right now, I have one student, Martin Garcia. He's actually in the one of the audience right now. But he graduated in summer 2020, and he actually started his master's program. And we are actually funding him through this NSF grant. And you know, he published he published 4 conference papers, and one of his journals is under review right now. And he out, as Fedra, you mentioned before that, but he outsmarted me. He's coming with projects. He's telling me, hey, let's do this one now.
Yeah,
You know,
they're the best kind.
I mean, yeah, I'm like, oh my God, look at them. You know, he's coming with ideas. He's telling me, I want to convert that into a compliance system. I want to develop a control lab equipment now. He wants to design a control lab equipment with actuation, but we have a limit. Our cost cannot exceed for more than $100. I'm telling I built a new team in fall 2020. I have 11 students working with me right now, even with COVID. So I have my team. I have ongoing 5 projects right now, and I have 2 teams working on the lab equipment that I have. And I believe that these lab equipments, especially for example right now, I cannot take these equipment to the lab, to my course, because we are in a rotating model. Only few students are coming to the face-to-face sessions, and most of them prefer taking this class as in online. So what I'm doing, I'm recording videos of myself, asking them questions. You know, very simple, because if you can understand the fundamental when you're an undergrad, then you can build more onto it. If you it doesn't matter if you just go into the field and become an engineer, or you continue in the academia and get your master's or PhD degrees, but still you need those fundamentals. And I believe these equipment, we have been doing research with Tris for a long time. We are creating the preliminary questions. We are asking them critical thinking questions. We're collecting them. We're going over them. And I believe we have an impact on that. And I love to see the impact on my students as well.
So I'm going to do something we haven't done before on this show, which is to call on one of your students. So Martin, I think you are on as a participant. And if you don't mind coming on, and if you do, that's fine. I don't mean to put you on the spot, but if you don't mind, I would love to hear from you about we would love to hear about your experiences working in the lab.
Hey, hello everybody. I've worked with Dr. Tekes. I think I started out with her, I think it's fall 2019. So I think it's a wonderful experience to get a hands-on and also learn other skills, such as most of the ME classes don't teach about electronics, except if you're taking a minor in another field or another major. So I think it's a wonderful experience to learn new skills, as well as apply the knowledge you learn in those classes, as well as seeing, because I was also her lab assistant for the control and vibration lab. So I was able to experience other students being able to use our lab equipment and also help them learn to further their education. So it was a wonderful experience.
So that's great. So tell us, so you're in a master's program now. Yes. What are your plans for your future?
So right now, I would like to finish my master's and also continue doing research, probably get some work experience out in the field, and as well maybe continue with a PhD here at Kennesaw or somewhere else.
Wonderful. And so are you in the lab right now?
Well, I'm in an office right across from the lab.
Is she making you work this Labor Day weekend?
Maybe.
You're supposed to say no.
Oh.
I'm just teasing with you. Thank you. I appreciate you coming on, and we wish you all the greatest success, and we're so glad that you're staying with us as a KSU owl for a couple more years. So that's wonderful. All right, I'm going to stop talking again and go to questions. So a question has come in that's from Mark Guile that asks about that the work that you're doing seems like a wonderful platform for problem-based learning. Tris, this might be maybe for you. Have you considered implementing any PBL modules using this approach?
Yeah, that's a great question, Mark. And if you look at what we're trying to build in terms of the activity designs for learning in the classroom or in lab with these devices, they're designed off of the POGIL model, which is sort of it's a process-oriented guided inquiry learning. So that's a form of related to problem-based learning in many ways. So we're trying to build significant learning experiences into each activity. Ayse mentioned before that they'll have some pre-lab questions, then they'll come in and there'll be a challenge that they have to face in the lab. Now, what we're not doing, Mark, is building in, say, a novel situation that they have to tackle with these devices in the class, although that could be something we could consider in the future. And then they go through some critical thinking questions to explore how this can be used to be applied in other types of problems before they go on. And if I can just add one more thing that, just to build off of what Martin said, when I'm listening to Martin talk, it really makes me think of there's different types of learning outcomes. And Dean Ferguson, you asked about all of the learning outcomes, and one form of a learning outcome is called an integrated experience. So that's what Martin is really getting at here, where we have an integrated experience that he's not just applying the content he's learning in class, but he's integrating it into a new engineering context and doing real engineering work. And I'm really proud that we're able to offer that to these students.
Great, thank you. Other questions? Don't be shy. Well, while we're waiting for more questions to come in, can you give us a demonstration of the things that are in front of you? You touched them, but I actually want to see them work.
Of course. This is super fun, especially now I'm teaching right now. This is the first 3 weeks. I only go over the fundamentals of vibrations in vibrations class, machine dynamics and vibrations class, and still students. So here I hope that you can see I have 3 springs, and I ask my students, you can actually create, so you can actually teach degree of freedom, starting with that. So we have 2 inertia terms. They are only, they each has only 1 degree of freedom. And I ask them, giving a demonstration. If if this was a face-to-face class, I will just take it to the classroom. But half means I just want to give them the same, option. So I'm just recording my videos for this. I just, give it an initial displacement and release the mechanism and ask students, what's the degree of freedom here? They just answer my question. But with the student design, I can actually lock one of the cards with a bolt, and I actually say, repeat the same question here. What's the degree of freedom? They will just say 1. Now, can you please tell me if these 2 springs are in parallel or in series? So they can comment on me because they see that both of them are deflected or stretched or compressed the same amount, making this connection parallel because they learned this in theory. So this system vibrates back and forth. It's obvious because we have mechanical springs. They're all 3D printed. The entire system with the optical sensors and Arduino, this only costs to $35. So we share the CAD model, and it's actually, anyone who has a 3D printer, which is like $300 around, they can 3D print at home. And I have already 5 of these sets, so I'm just happily giving it to my students. Then I ask the same question with this system. This is a rotational system with 1 disk. I give it an initial rotation and release. The disk rotates back and forth. We call this still free vibration. And I ask my students, I do not have any spring here. So why do you think this disk rotates back and forth? If you have a box, and if I move the box doesn't move because there is no spring element. Here, I don't see any spring as in this translational system, but still this disk rotates back and forth. There's an optical sensor they can measure. I have an optical sensor here. They can connect this to an Arduino, and then they can read the angular position. This costs you only $15, $20. And the students struggle here. It's easy to see on a translational, but it's not that easy on a rotational system. I explain them in your vibrations class. You learn this. Anything thin and long serves as a spring in a system, and they love it. because this was my struggle. I never understood the topic, like, okay, anything thin and flexible. Also, not all systems have mechanical springs. We designed this system pretty new. We just published this in Ayse Make 2020 conference. And look at how professional Martin designed this system. And they can attach, here there's a magnet which lets you attach the box, and you can attach boxes on the mechanisms to change the mass. But this system is actuated. I'm using a linear actuator to demonstrate fundamentals of resonation and isolation. This system helps students to design a vibration isolator. Once you run it, I have videos of this. When we're done with the project, my students who designed the system, they record a video of themselves, and then we just share it in YouTube also, so anyone can see our project after we publish the paper. But these are such amazing projects. These are only few. So right now there is one. I asked Martin to create this system for me, and he just, brought this in to me like in 2 days. Because anything flexible, like this is another topic that we teach in vibrations, we have a cantilever beam, and I asked them to find the stiffness of this cantilever beam. One way to do this is using the stiffness coefficients provided in the tables in their textbook. Another way is you can attach a load, and then you can actually read the displacement. I wish I was able to give them, print 50 of them and give it to the students, and they can actually print out to determine if this is a linear or a nonlinear spring. So lots of fun for undergraduate level, lots of fun for free. They're super cheap. If you start actuating them, you increase the cost. So we have new projects going on. More fun.
Great, awesome. That was really exciting. We do have a hand up, Laura Ruhala. You want to ask a question?
Hi, congratulations to both of you, Ayse and Tris. It's so amazing.
Thanks.
We're so proud of you. Yeah, I was wondering, what are some of your tips for best practices in conducting the research while still social distancing? And you have a lot of students in a lab. Do you have some thoughts you could share, maybe?
Of course. Usually, if anybody visits my lab, you will see some students sitting on the floor, some are on the computer, some are on the this round table I have. But with COVID, everything changed. So we are only allowing 2 students at a time. And plus, don't share this with anyone. I cannot say this anymore, but this is recorded. There are so many free offices right now here in Northern Hall. Nobody uses, and nobody's allowed to use them, but the doors are open. So whenever I have a student coming in, and I have already, let's say Martin and another student, let's say Martin and Paul are already working in the lab, so the third one cannot come in. He only gets, for example, the student just gets the equipment, and then I ask him or her to move to those offices. I have free, like 3-4 rooms right now, but let's say in the future, if these rooms are not available, we will be rotating. I will never let 3 people stay in the same room. If one of them is, they don't need to wear a mask, but if I have 2 students in the lab, they have to keep the social distancing with their mask. And I have Clorox, our lab is right now crystal clear, clean, super clean.
Thank you. Your public health officials appreciate your adhering to our policies.
This dean also has a sledgehammer, which might be able to be used to adjust offices into additional lab space. But again, I didn't share that.
But thank you for that question, Laura, and for the response. There is another question in here. There's 2 questions. One is, and maybe you've already answered this, but your students being able to do the 3D printing using their own equipment at home. And I think that's been happening all along, right?
It is happening all along, because this one, for example, not all my 3D printers are expensive. I have a 3D printer which only costs you $250, and you can actually print this on that 3D printer with the filament. And this will only cost you $3, and if we really share the CAD models.
And that's actually part of the goal. I'll just add in that part of the goal with the research is to develop models we can share through the internet where anyone can download it at any university and use it in their course. So even a student who doesn't have a professor using this equipment might discover it, print it out, access the learning materials, go through it and learn about it. They don't even need their class to be working on it because they have ability to do that. And we started out before we got the funding with these very inexpensive printers that students, some students are able to afford at home.
Great. A good question has come in about the future direction of your research.
Yeah, wonderful question. So we want to be the leaders in this research. There is still an ongoing effort in as I mentioned, in lowering the cost of these educational lab equipment, but I want my team to be the leader in this area in the future.
And I might just add that we have this blessing in disguise, I suppose you might say, and that one of our opportunities here is to actually explore online small group learning with hands-on learning, because these devices are small enough and light enough that we can actually mail them to a subset of students who can lead a team that could meet on teams like this. The student can operate it and they can explore together, even in a completely online environment, how this works and get their hands dirty. So we're excited about that. It's a bit of a blessing in disguise.
Yeah, thank you for that. And, I think everything we're learning in academia is going to look different after COVID, and we learn from these experiences. So what more do you need to become successful? So I heard you, and I love your goal. We want to be the best. We want to be the leaders. What will it take to get there?
I think first, money. You will definitely need money to continue on this research, and hopefully for 3 years we have the money. That's wonderful. And I need good students. From here, I'm just calling them. Whoever wants to get the hands-on experience, please approach us, become part of our team. Right now, I have 11 students, but I would love to work with more. Every semester, I'm working with those, ambitious students, wonderful students. And they all have goals. They all want to change their lives. So I want to be I want to work with them also. But in the 5 years, what I would need is really good students and great ideas, because we cannot come up with copies. So this is not a copy. This is my compliance system is my PhD research. But I have never seen this kind of a laboratory equipment developed before. So we need to come up with novel ideas, really novel. We're not copying any turnkey systems that already exist in the market. We are developing novel equipment, so that's why I need more students, and I have to do more literature review, and I should keep writing maybe proposals after this with Tris.
Yeah. Can I just add one thing? I think that we also have an opportunity to seek out integration with industry partners who might have novel applications that we can simulate. Because one of the things we're trying to do with the learning activities is have students connect this not only to the math and the theory, but to a variety of real-world applications. So any one of these devices, we can say, okay, where do you see this in the real world? And we can talk about those and we can show them videos of some of those. But if we have partners who are working on projects that are directly related to this from industry, then they have a connection that goes even beyond that level in the learning. So that's something that we can also develop.
Absolutely. All right, I'm going to ask one final question, which is wondering if you frame your research within the open science movement.
Can you, I guess not directly since we're, can you just elaborate a little bit?
I can elaborate a little more. So congratulations. I'm impressed by the work you are doing. I was asking these questions in regards to the open science movement because I was thinking in the students we have in the Bagwell College of Education. We train future teachers, and I believe your work would be super useful for us to help train future teachers. But also, if what you produce is within the open science movement and it's open to teachers at schools, I'm sure they would love applying all the knowledge you are generating.
That's actually one of our plan, right, Tris? In the proposal, in an NSF proposal,
Yes.
we really reach out to the local schools. And one thing that in April that I saw that this is coming, that with COVID everything will change, and we are gonna move online, and the instructors won't have enough time to go to their lab, record the videos, and record videos and collect data to be able to provide it to the students. I knew this is coming, and I knew that we will not be ready for that too. So because of this, I already had one of my honors student, Paul Pena, and I asked him to learn MATLAB Simscape. All summer long, I was working with him crazily. I asked him to develop a MATLAB GUI program, but not many people are familiar with MATLAB Simscape. So he's now master in MATLAB Simscape, and he created a GUI program that I myself used for the for my summer vibrations class. Right now, Dr. Richard Ruhala, he's using that MATLAB Simscape program, GUI program that my student created. Now, actually, the same student who is giving workshop for my new students on Wednesdays at 8 p.m. through Teams. We meet, on Wednesdays 8 p.m. We meet through Teams, and he actually shows us how to use MATLAB Simscape. All of us. I mean, in the future, we are going to do more than hands-on equipment. Maybe we will do also so many animations and GUI programs. So we will be directing in every area. We want to be in every area of teaching fundamentals of dynamics, vibrations, and control.
Great, thank you. And how perfect that we end on that question, because that question came in from Yvonne, who is a professor of educational research in the Bagwell College, and he is going to be our featured presenter in 2 weeks on this at this very time. So with that, we're going to wrap up today's show. I always swear to end by 5 p.m. because people want their weekend to start. And so I'm going to do it this time also. A big, huge thank you to Ayse and Tris, not just for doing this for us today, but also for all the great work that you're doing with our students. You are an inspiration to so many of us, and I really, really have enjoyed getting to know you more this week. I hope you all from the Office of Research have a wonderful and safe and happy long Labor Day weekend, and we look forward to seeing you back here at 4 p.m. in 2 weeks' time. Thank you so much.
Thanks for having us.
Thank you. Have a good weekend.
Thank you.